Hello, this is Nova Top Flex, and in this video, I will be reading some of the earlier RFCs, the historic ones of fewer paragraphs than the other RFCs, really. So RFC number 13 was not significantly long. Request for Comments 13 on August 20th, 1969 was about Request for Comments 11 being referred to, appearing that file transmissions over auxiliary connections would require some mechanisms to specify end of file, sometimes abbreviated and often abbreviated as EOF, especially in computer science. Proposed that a length 0 message had been used for that purpose, and Request for Comments 13 would have a diagram. There are some requests for comments, such as RFC 12, that are entirely or majority comprised of diagrams. Now, RFC number 16, I already went over. That's not too long, but it is not that short either. And then RFC number 17 is actually another fairly short RFC, just about some questions for the host IMP protocol, or might not have been that short, actually. So there was an introduction for 7 about the preliminary software design of the host IMP interface, and then the scope was supposed to be the two main programs, handler and network. The network program was supposed to be about the multiplexing and distribution. Output message processing was supposed to be about text location, text length of bytes, and destination, with the network program preparing a 16-bit host heading and inserting a 16-bit marking between the header and the text, so as to begin text at a word boundary. And also to verify, we'll check the length of a user's text if it exceeds 1006 bytes to an 8080 maximum host message length minus 32 for heading and marking, for 8 with 1 byte equaling 8 bits. And then the program would break down the text into a sequence of messages up to 1006 bytes. Handler program was supposed to be initiated. Sorry, that was RFC 7 that was reading, not RFC 17. That's the host IMP interface. Handler program is initiated either by the network program or by the I/O interrupt. And the program, very short, code into master mode and integrated in the input-output supervisor of the operating system. Controlling the channel hardware unit, emptying the buffers filled up by the network program, exploring and updating the interface table, and eventually ensuring a control transmission procedure with the IMP. And then questions below after the buffers and interface table. The buffers should be large enough for containing the maximum host message text plus heading and marking. 1006 plus 4 equals 1010 bytes equals 8008 bits. And consequently, 256 words or 1024 bytes for the buffer size to be equal to. As for the buffer number, that would determine the link utilization frequency. For the interface table, it is through that table that the network program would inform the handler of the location and length of the data to be emitted. The table could be a ring table with 2 pointers, one for filling, the other for extracting, respectively updated by the network and the handler program. And then there are diagrams as well in some of these. RFC 7 has one diagram about filling pointer and extracting pointers. And then, why is there not a simple control procedure between the host and the IMP? What happens if a message issued from the host reaches the IMP with an error due to transmission? At the time, the BBN specifications had the error transmitted as far as the receiving hosts, in which a host-host control procedure supposedly needed to be provided. And then the special channel hardware unit, MIOP or SIOP. How will the device be notified of an outgoing message end in order to start the padding? Well, the program would provide to the MIOP, SIOP the number of bytes to the outgoing message, and then receive back an interrupt with the last byte sent out. That's for Request for Comment 7. Handler know the length of the incoming message as well. And then the Gordo documentation available to design the user network program interface with program initiations, transferring parameters from one program to another, also with a diagram and more diagrams, and this was Request for Comments 7. Sorry about the detour. Request for Comments number 17. Like the Request for Comments number 13, but unlike number 7, number 17 is also fairly long, similar to 7, with automatic deletion of links, where the questions about the host IMP protocol, RFC 17, questions from RFC 7. So link use may be dependent upon human use of a timeshare terminal with indefinite time between messages, and the program using link may be slow due to busy hosts with many jobs or much local input-output and or central processing unit time between messages. I/O and CPU, is it that if a host user fails to use a link for 15 seconds, the host must generate a dummy message merely to keep the link open? And then C. Crocker, Host Software, April 7, 1969, had asked on page 2, can a host, as opposed to its IMP, control RFNMs, request for next messages? BBN, report number 1837. July 1969, and that says on page 2, the principal function of the IMP program includes generating a request for next messages. What if an IMP generates a request for next message and then discovers it cannot, for some reason, complete timely delivery of the last received message to its host? Seeming especially pressing since it doesn't recall seeing anywhere an IMP constraint upon hosts that they must accept incoming messages within some specified maximum time. Number 3, a host had to be prepared to repeat transmissions of message into network. Therefore, why the special discardable NOP message, page 12, BBN number 1822. Arbitrary delays from the middle paragraph, page 23, BBN 1822, seems inconsistent with automatic link deletion questioned in one above. Normally, the times involved differ by many orders of magnitude, but a high priority non-network host responsibility could delay next bit for a long time. Not much else in the main request for comment 17, but spurring off of it is also request for comment 17A with NWG Network Working Group 17. So John Kresner's questions, the deletion of a link entry from an IMP's link table will, in general, have no effect upon a host transmission or reception at the IMP site. Let's distinguish between non-use of a link in between messages and non-use of a link due to host program delays in the middle of transmitting or receiving a message. When the host transmits a message on a link for which an entry is not in the link table, one will simply be inserted there. No need for dummy host messages to keep the link open, since the link is effectively always open. Only if the link table becomes full immediately after an entry is deleted, a situation that was not expected to occur at the time, the possibility of resulting delay introduced by host programs, which is also not inconsistent with the link entry deletion procedure, which is blocked when the first access of the link table is made during transmission from the source IMP and is unblocked when the RFNM returns. Only non-blocked transmit links entries are deleted after 30 seconds of disuse. The statement on page 23 referencing arbitrary delays is only intended to have hardware implications insofar as the host IMP interface designed to transfer bits asynchronously between the host and the IMP. The request for next message was returned from the destination IMP to the source IMP when a message reaches the head of the destination's output queue to the host. For instance, just before a message is sent to the host. If a destination IMP cannot then deliver that full message to the host, at most one more message may possibly arrive in the IMP due to the premature release of the RFNM. The new message will subsequently take its place at the end of the output queue to the host, thus guaranteeing the preservation of the proper message arrival sequence. The NOP message is a special control message which is available for use during initiation of communication between the host and its IMP. The host may, of course, decline to send NOP messages during this period, but the first received message after IMP startup or after the host ready indicator has gone on may be discarded by the IMP. We do not require hosts to be prepared to repeat, they do not require hosts to be prepared to repeat transmissions into the network. This was Bob Kahn and Network Working Group, RFC 17. There are other similar RFCs, whether they're longer in the mid-range like 7 or 17 or shorter like 13. Additionally, with RFC 18 is actually, despite some titles suggesting longer requests for comments, others may not be as long. For instance, the VintSurf RFC 18 suggested, so this was the category was IMP, and host control links. And for RFC 18, it was suggested that link 1 be used for the host and link 0 for the IMP control, and facilitate communication between hosts and reduce delays due to interference with IMP communications, with this request for comments restored by Elmer K. Binns. This is request for comments number 18. 2 protocol suggestions to reduce congestion at swap-bound nodes. RFC 19. The two in question for RFC 19 were host control of ordering of IMP to host traffic and core-to-core transfers between hosts, with a wide variance in swap rates between core and auxiliary store among the host systems to be nodes in the ARPA IMP network. The slower, the 36050 with 2303 dump swap store as an example, might have improved the network's utility not only for themselves but for all nodes. The two protocol suggestions were to be adopted. With host control, IMP hosts had called for delivery messages from IMP to hosts in the order in which the IMP received them, leading to wasted swapping if, for example, the IMP has messages for its host timeshare users A and B in that order at a time when B was in host core. B would have to be swapped out, A in, and the first message accepted, only to discover that now A must be swapped out and B back in again. The host could read the IMP's queue of rating messages and B accept them in the order it found most effective. Then a new mechanism for improvement in network efficiency would be at hand. Clearly, that change would have had an impact on the BBN IMP software, and core-to-core transfers between hosts at another level, perhaps not involving host IMP or IMP software changes, was the host-host protocol, wherein cooperating hosts agree to lack appropriate programs in core for the duration of a multi-message file transfer on an auxiliary connection. This could greatly reduce the time to transfer such a file to and from a swap-bound host. Unfortunately, the numbers mitigate possible advantages of this approach to some extent. If a 50 kilobit per second line is assumed and supported further that it was dedicated 100% efficiency to this transfer, requiring slightly different handling of requests for next messages in that case, came out to just over 8 kilobit messages per second. And impulse in a timeshare environment to lock a single program in core for more than about 2 seconds. If that's the case, then the method would be applicable only for the rather limited range of file sizes of 2 to 16 messages. Nevertheless, the time to move a large file could have been so greatly enhanced by this approach that it could have deserved consideration. That was Request for Comments 19. Request for Comments 20 was about the ASCII format for network interchange, which is a fairly long one. This video focuses on the mid and short range RFCs, so RFC 20 will be for another video. I will focus on the short RFCs up until the last one, prior to, or 30, whichever comes last. RFC 21 was fairly short. At UCLA on October 10th, 1969, was a network meeting attended by 4 from SDC, 4 from UCLA, and 3 from UCSB, with discussed topics to revisions to BBN 1822, Network Working Group Request for Comments 11, and transmission of multiple control messages. Changes to BBN 1822, as informally communicated by Dave Waugh, were that on page 11, the IMP program handling up to 63 active transmit links and 63 active receives, so 63 and 63, and attempt to send a message on new when 63 already exists. A link table full. Now, there's a 26-second limit before the entry is automatically deleted by the IMP program. From Surf, how about deleting only the transmit link table as full? Crocker, no, because there's no other way for links to be deleted, so they always tend to accumulate. Furthermore, the table at one site may be full while another site may not be. Page 13. 5 regular with discard, allowing IMP systems to generate traffic which never actually reaches any host, since it will be discarded when it reaches the top of the IMP host queue and the destination's host IMP. The Network Measurement Center will make use of this feature. Message type 6 is no longer assigned, and 10 is really an octal, so it's actually type 8. Types 9 through 15 are unassigned for page 13, and for page 17, type 10 was really type 8. For Network Working Group Request for Comments 11, the memo had been obsoleted by developments at UCLA and discussions with other nodes. Network Working Group Request for Comments 22 contains some of the major changes, with a forthcoming updated version of Network Working Group Request for Comments 11. Updates were intended to be in Request for Comments 23, transmission of multiple control messages. RFC 22 is longer, so it will be for another video. This will focus on the short and mid-range RFCs, Request for Comments. Request for Comments 23, transmission of multiple control messages. On October 16, 1969, G. Gregg stated that the network program at a site must be prepared to send or receive more than one control message in a single control communication. During the time that the control link was blocked awaiting request for next message, possible the number of control messages to a particular remote host would accumulate. While the link was unblocked, then they should all be sent in a single communication with the greatest efficiency. For receiving, necessary to have a loop returning to decode and take action on successive control messages until the control communication is exhausted. Transmission of multiple control messages, RFC number 23, UCSB.